Hey everyone, Krishna this side, and I welcome you all to this channel. So let us solve this LeetCode question 2348, number of zero filled subarrays. Okay, question marked as medium, but it is actually easy question. Given an integer array nums, return the number of subarrays filled with zero. A subarray is contiguous non-empty sequence of elements within an array. Okay, let us see what the first example trying to say and what output it is basically expecting. So we are given an array. So when we try to see a sub array which is basically filled with zeros, right? So individual element can be a sub array, right? So here this zero basically can be a sub array. So the count is basically one. Again, this is also sub array. Count is basically two. This is third and this is fourth. So four subarrays we noticed basically having only a single zero element in that particular subarray, right? So it is basically four. Now again, when we try to see this zero zero, also again another subarray which is basically filled with all zeros, correct? So here it is again another count, right? Then this next subarray is also another occurrence. Okay, so in total so far, like this zero single element subarray basically appeared one time. This basically appeared two times. So in total six subarrays we notice here, okay, which basically filled with zeros. So that is something what we have to count and we have to return. If we look into the next example, here this particular subarray also we can consider, right, because it is actually filled with all elements as a zero. So in total, again, like this individual zero appeared five times. This two zero array, if you try to notice, they appeared basically three times, and this entire sub array is also filled with zero, so it basically appeared one times, which has in total three elements. So yes, when we try to add all of them, so basically the subarrays are 5 plus 3 plus 1, 9 subarrays that we have, which are basically filled with zeros. That is something what we have to return, right? The question is pretty much easy and straightforward. When we look into the constants, it is basically 10 to the power of 5, and this nums of I, it goes all the way to 10 to the power of 9. Okay, let us see. Let me connect the screen and I'll explain very quickly, and then we can write down the code as well. Now here in this particular example, when we carefully observe this particular zero as a single element subarrays, when we try to count, so it appeared 1, 2, 3, 4, 5. 5 times it basically appeared. So all these are basically subarrays, right? So individual element can be a subarray. Now next, when we try to consider twos pair, right? Subarrays like this. So they appeared basically one, two, three. Three times they basically appeared. And this entire three element subarray is also filled with zeros. So that is also we can count. This is also another subarray. So in total, it basically appeared one time, right? So all this count when we add them, so it is like nine subarrays. That is something what we can notice right over here. Correct. So how to approach this particular one, right? So when we try to go brute force way, like keep on counting like where zeros basically appeared. So single zero, how many times it appeared, then two times zero, how many it appeared. So it is going to be n square, right? Basically. So we'll run two for loops and we'll keep on checking like how many times this two zeros basically appeared, three zeros basically appeared. Correct. When we try to do that, it is basically n square, and that is something what we cannot accept based on this constraints as well. A simple approach that we can follow. So do you remember this particular thing? Like this is question, right? In childhood, we usually have this. We just have to count how many rectangles basically we have in this particular one. So ideally, when we try to see, this is one rectangle, this second rectangle, this is third rectangle, correct? Then this can be another next rectangle, this can be another next rectangle, right? So in total so far we notice five rectangles. Now lastly, this entire can be a rectangle as well. So in total six rectangles we have. So how we basically calculate them? So it was pretty much easy. So we mark them based on their indices, like here it is 1, 2, 3, and we simply add them. So in total, it is basically 6, and that's how we basically calculate them. So same logic, simple, we will apply right over here as well. So whenever we see any zero, okay, let's suppose these are the zeros that we notice. So we will maintain a count and a total answer so far that we are getting it. So the moment we notice zero at any point in time, here the zero is basically we notice the count got increased. Okay, count is basically equals to 1. Okay, that's how we are also pointing here the same thing, right? Now in total we will simply add that count, whatever the count that we are getting it, we'll keep on adding the count. Okay, in total. Now the moment another count we noticed, another zero simultaneously we noticed, the count, whatever the previous count that we have, it got increased. Okay, so at the first time also, whenever a zero appeared, we simply increment the count by one. So same thing we are doing it. The moment zero appeared, we are just simply increasing whatever the count that we have. And this count is something what we will keep on adding it into the total answer. That's the same logic we have done, right? So here, the moment we saw first rectangle, we added one as a count. Next, another rectangle immediately we saw, so count basically got increased to 2. Next, again, third rectangle also immediate to that we have noticed, so the count is basically 3, and all of them we simply added. So here, whatever the initial count that we got, it got added into the total. So initially for this particular index the count was 1, for this index the count was 2, for this index the count was 3, and for this index the count was 4. So these are the values that is something what we will keep on adding it. In total the answer for this particular one was 10, right? So whenever this particular subarray is something what we notice, right, definitely the answer is going to be 10. How? So for single subarrays, they are total 4 subarrays we notice, right? Whenever a single element is something what we are considering. Okay, for 2, they are basically, this is first, second, third. Okay, so this is how things will go. Like single subarrays, we notice there are 4. 3 are subarrays which has having 2 elements. Okay, now 2 subarrays which has 3 elements. This is 1, this is 2, right? And one subarray is there which has entire 4 elements. Okay, that's how the answer basically it's calculated. So simple, right? Let us try to write down the code as well. Let me just disconnect it, and let us have here a count variable. Count equals to 0, and then int total equals to 0. So we should consider here long. Okay, that's how the question basically designed. We'll run a for loop, int nums. Okay, if this num is basically equals to 0, count plus plus, simply add it into the total. Total plus equals to count. Else just restart the count. Count equals to 0 if it is not equals to 0. That means the element is, if the element is not 0, then we will simply restart it. Simple. We'll now return this total. That's how we can form this particular one. Okay, let us try to see if it is working fine or not. Let me try to submit this code. So if you talk about the complexity, it is simple, pretty much big often is something the complexity that we are having here. That's all from this particular video. Thank you for watching this one. Bye bye.